Welcome to Module 5, Array. In this module, we will learn how arrays store data of the same type and how to perform operations using code and observe the outputs. This slide shows that array elements are accessed using index positions starting from 0. Each position stores a value, and we use the index number to retrieve or modify that value. Arrays store elements of the same data type and are accessed using index positions starting from 0. This makes them efficient for handling structured numerical data. This slide shows the definition of an array. An array stores multiple values of the same data type. Unlike lists, arrays do not allow mixed data types. For example, a list can store numbers and text, but an array stores only one type, such as integers. Arrays are used when working with large numerical datasets, matrices, or scientific computations where efficiency and speed are important. This slide shows the syntax for creating an array. The format is array, typecode, elements. The typecode defines the data type, and the list contains the elements to be stored in the array. This slide shows different typecodes used in arrays. For example, I represents integers and F represents floating point numbers. This ensures all elements in the array are of the same type. This slide shows how an array is created and printed. First, numbers equals array, I, 1, 2, 3, 4. This creates an array of integers. Next, print, numbers, output, array, I, 1, 2, 3, 4. This shows both the type and values. Then, print, list, numbers, output, 1, 2, 3, 4. This converts the array into a list and displays only the values. The built-in array module supports only one-dimensional arrays and cannot directly create rows and columns, 2D arrays. For 2D arrays, use NumPy from external library, when working with large datasets and scientific/data analysis computing. This slide shows how to create a 2D array using NumPy. A equals np.array, 1, 2, 3, 4, 5, 6. This creates 2 rows and 3 columns. Output, 1, 2, 3, 4, 5, 6. NumPy displays only values without showing typecode. This slide shows how to find the length of an array. B equals array, I, 10, 20, 30, 40, len, b, counts the number of elements. Output, 4 so the array contains 4 elements. This slide shows how length works for 2D arrays. Len, a, returns number of rows, which is 2. A.shape returns the dimensions of the array. Output, 2, 3, means 2 rows and 3 columns. This slide shows how to add an element using append. ARR equals, 10, 20, 30, ARR append, 40, this adds 40 at the end of the list. Output, 10, 20, 30, 40, the new element is always added at the last position. This slide shows how to insert an element at a specific position. ARR equals, 10, 20, 30, 40, ARR insert, 2, 25, this inserts 25 at index 2. Elements from index 2 onward shift to the right. Output, 10, 20, 25, 30, 40. This slide shows how to update an existing value. ARR equals, 10, 20, 30, ARR, 1 equals 25. This replaces the value at index 1. Output, 10, 25, 30, the original value 20 is overwritten. This slide shows how to combine 2 arrays using the plus operator. A sadface 1, 2, b sadface 3, 4, c equals a plus b. This joins both arrays into one. Output, 1, 2, 3, 4. This slide shows how to combine arrays using NumPy. np.concatenate, a, b, this merges 2 arrays into one continuous array. Output, 1, 2, 3, 4. This slide shows how extend works. A sadface 1, 2, 3, b sadface 4, 5, 6, a.extend, b, this adds all elements of b into a. Output, 1, 2, 3, 4, 5, 6. Unlike plus, extend modifies the original array. This slide shows methods to remove elements. Remove, deletes by value pop, deletes by index del removes specific positions. Each method affects the array differently. This slide shows step-by-step deletion. Start, 10, 20, 30, 40, remove, 20, removes value 20, 10, 30, 40, pop, 1, removes index 1, 10, 40, del ARR, 0, removes index 0, 40, each step updates the array. This slide shows slicing. ARR equals, 10, 20, 30, 40, 50, ARR, 1, 4, 20, 30, 40, starts at index 1, stops before index 4 ARR, 3, 10, 20, 30, ARR, 2, 10, 30, 50, step 2 skips elements. This slide shows built-in functions. Functions like append, insert, remove, pop, and reverse are used to modify arrays. These functions help manage array data efficiently. This slide shows NumPy functions. Functions like np.max, np.min, and np.mean perform calculations directly on arrays without loops. This slide shows a 2D array example. A11 accesses row 1, column 1 value 5A11 equals 55 updates the value output shows the updated array with 55 replacing 5. This slide shows adding rows and columns. Stack adds a new row, stack adds a new column, the array expands in size accordingly. This slide shows removing rows and columns. np.delete, A1 axis equals 0, removes row index 1 np.delete, A2 axis equals 1, removes column index 2, the array shrinks accordingly. This slide shows the comparison of data structures. Arrays are best for numerical data and calculations, while lists, tuples, and dictionaries are used for more general data storage.